And now we get to these questions which I was telling you that occur only specifically when you have something that is above the ground. Here, I'm going to work with you to find out the impact speed that the stone takes to land in the water. So what we want to work out is essentially the velocity as it lands in the water. And not the horizontal velocity, not the vertical velocity, but the velocity of the actual projectile motion object itself. So we want essentially that velocity, but over here. So what we want to find out is that velocity there. Now, similarly to how with that velocity there, we could draw ourselves a right angle triangle, we can do exactly the same thing. So we can say that this here, that's going to be our vertical velocity, right? Whereas that here is going to be our horizontal velocity. Now, it doesn't make a triangle quite yet, but if you take this here, now this is exactly the same as that. So if you take that y to equal that, then you can see that we have this triangle here. Can you see how we have that triangle there? That's right angled, which is similar to the triangle we have there to work out the impact, so that velocity there. Which means to work out that velocity, I need both my horizontal and my vertical velocity. Let's work out our vertical velocity. So our vertical velocity there is given to us by this equation, which we worked out previously. Now the vertical velocity, remember how it changes throughout time? The time here, it was 4.01. So just substitute that in. So the vertical velocity as a stone hits the water is -10 multiplied by 4.01, which is the time, plus this, which equals to approximately -28.79 meters per second. Our horizontal velocity, we can just work out from differentiating our horizontal displacement, which was 8 square root 2t. So just differentiate that, you get 8 square root 2. So now it's just easy Pythagoras. So you know the impact speed will be the square root of that squared plus that squared, like that. So your vertical and your horizontal velocity there. Now putting that into your calculator, you get that this v here, that velocity is 30.93. So what that is the impact speed, so impact velocity of the stone as it lands in the water is 30.93 meters per second. All right. Now, just remember for this one, what we're doing is exactly as what we did right at the very start. We said that's our velocity, and we can divide that into vertical and horizontal velocity. And when we do that, we made this right angle triangle, exactly what we're doing here. That's our velocity there. We had our vertical and our horizontal. The only difference was I moved that over there, okay, to form a triangle. And then it was just simply some Pythagoras, wasn't it, to work out what the velocity was as a stone hit the water. Excellent. Okay, so this is another question which is unique to questions above the ground. And this is finding the impact angle that the stone takes to land in the water. So in the same way, we have our velocity, remember, there, and there was our vertical velocity there, and there was our horizontal velocity there. And all I did was I transposed that to this side because I said it was exactly the same and made myself this triangle there. So we worked out already that this was 8 square root 2 and that was -28.79. So how am I going to work out this angle there? What we're going to do is just tan theta, right? So you just have opposite on adjacent. So in this case, it's just -28.79 on 8 square root 2, which equals to approximately -2.54, etc. But keep that value exact in your calculator. And then we do inverse tan of that value, which equals to approximately negative 86 degrees and 33 minutes. Now, negative is an interesting concept here because what I need you to think about is that there is a line here, okay? And anything that goes from here is positive. So this is your positive angle over here, whereas this over here is your negative angle. So anything going from there is your negative angle. So here, because it's negative 86 degrees and 33 minutes, it's going to be that angle there, which is 86 degrees and 33 minutes, okay? So just remember, negative on this side, positive on that side. Just commit that to memory. You know that this here, negative 86 degrees and 33 minutes, is the angle that of the impact as a stone hits the water. So just remember for these ones, when you want to find out the impact angle and the velocity as a stone hits the water, we're not worrying about vertical, horizontal. What we're worrying about is that big V that I showed you before.